of what I started with in Igcse physics last time. And in that particular video, I started with the Vernier calipers. And in that video, basically, I tried to explain you the basic concepts of a Vernier caliper. And I explained you in detail what is a least count of a Vernier caliper. And now, in continuation to that video, now we are going to talk about property or property of a Vernier caliper, which is known as a zero error. Okay. Now let us see what this zero error means. So in a Vernier caliper, what do you mean by zero error is a Vernier caliper, once it is used for too many days, or say for a longer time, what happens is there may be an error which may come into the Vernier caliper, which may come in the form of something called wear and tear in the Vernier caliper. Now, what happens is normally, if you see this particular diagram, okay, have a look at this particular diagram, right? Here you can see that the zero of the main scale, that is this, and the zero of the Vernier scale, that is this. Okay, they are both exactly coinciding with each other. Okay, now this is happening when both the jaws, the external jaws, okay, what I mean is the external jaws, when both these jaws are exactly touching each other. So when the jaws are closed, if this thing is happening, that is the zero of the main scale and the zero of the Vernier scale are both aligned, are both along the same straight line. Okay, they are not disaligned. Okay, so in such a situation, we say that there is no zero error. Okay, there is no zero error, or you can say that zero error is nil. Zero error is nil. Okay, you can say no zero error or zero error is nil. Zero error is normally denoted by ZE, and in this case, ZE will be nil. Okay? This is what happens when the Vernier caliper is a new one. Okay, it has not been used for a pretty long period. Okay, so I will do one thing. I will also show you a Vernier caliper which I have right now with me, and it's really a brand new one. Okay, can you see on the screen this Vernier caliper? Now this Vernier caliper, let us check. Now if I close these two jaws, okay, if I bring these two jaws together, close them. Yeah, now it is closed. Now if you can see properly, now I don't know whether you can see it, but I'll zoom it in. Yeah. Now when I zoom in, you can see that the zero of this Vernier and the zero of the main, they are both exactly coinciding. Okay, they are in the same straight line. So this is a situation where you can say that the zero error is nil. Okay, but after say you know certain amount of time has been passed, and if I'm using this particular Vernier caliper for a very long duration, or suppose I'm using this Vernier caliper very roughly because maybe so many students are using this Vernier caliper, so what may happen is this alignment of the main scale 0 and the Vernier scale 0 may get disturbed. Okay. So what may happen is there are two cases that can arise. Either the Vernier scale 0 or the zero mark of the Vernier scale will shift to the right of the zero mark of the main scale, or it will go to the left of the zero of the main scale. Okay, either thing can happen. So in either of this case, we say that a zero error has been introduced into the Vernier caliper. So now I'll take you back to the the home screen. And yeah, so here is the case where you can see now, if you see this diagram, I want you to see this diagram now. In this diagram, you can see here the zero of the main, yeah, zero of the main is somewhere over here. Can you see that green mark? And the zero of the Vernier, you can see it is on the right over here. Okay, and see they are not coinciding, right? So this is a case where you can say that zero error is having some value. So zero error is not nil. Okay. So here you can say that zero error has been introduced into your vernier caliper. Here the zero error is nil. Okay, because your main scale 0 and the vernier scale 0 are both aligned. Here you can see that the vernier scale 0 and the main scale 0 are not aligned. Okay, they have been disaligned. Okay, so this is a case where we say that zero error has been introduced into the vernier caliper. Now, if you go ahead and see two more diagrams over here, that is this one, the third diagram, and the fourth diagram. If you see these two diagrams carefully, you will observe that both these diagrams, okay, are showing you which is a purple color, right? Now, in these two diagrams, this and this, right? You can see that in this case, now if you see over here, can you see that the main scale 0 is over here and the vernier scale 0 is to the right of this particular uh, 0 of the main scale. Okay, so this is vernier scale 0 and this is your main scale 0. Okay, now can you see both these zeros are not only disaligned, but you can see that the 0 of the vernier, this is your vernier scale, right? So the 0 of the vernier scale, that is this 0, is on the right of the 0 of the main scale. So this situation you can write it in this way, that the 0 mark of the vernier scale is to the right of the 0 mark of main scale. Okay, if this situation arises, we say that positive zero error, I'm writing ZE. Okay, a positive zero error has occurred. Okay, now what is the value of this positive zero error? If you want to ascertain the value, you start from the vernier scale 0. Okay, so you see start from the 0 of the vernier scale and you go to the right and see which particular division of the vernier scale is exactly aligning with the main scale division. Okay, so if I see this 0, it is not aligning exactly with any of the main scale division. In fact, it is in between the first two main scale division. It is not aligning. Even the first division, this one, is not aligning with any main scale division. Even 2 is not aligning. Even 3, 4, 5 is not aligning. But I can see that this sixth division of the vernier is in a straight line with the main scale division. Okay, so this value is 6. Okay, I'll pick up and I'll multiply with the least count of this particular uh, vernier caliper. Suppose the least count now, why suppose the least count of this vernier caliper is 0.01. Okay, so 6 multiplied by 0.01 will give me 0.06 centimeter. This is my zero error, and because it is positive, I'll put a plus sign in front of this. So this is how you have to determine the positive zero error. In the second case, you can see similar situation, but a slight difference. The 0 of the vernier scale, can you see here? The 0 of this vernier scale is to the left of the 0 of the main. Okay, so here I can say that the 0 of the 0 mark, okay, right, 0 mark. Okay, I can say that the 0 mark of the vernier scale is to the left. This time it is to the left of the 0 mark of main scale. Okay. Now, in such a situation, we say that negative zero error negative ZE has occurred. Okay. Again, if you want to find out the value of this negative zero error, repeat that same procedure. You keep on going from left to right, okay, on your Vernier scale, and see which very first division on the Vernier scale is coinciding exactly with the main scale. So if I go and do that, the zero division is not coinciding. The first division is also not coinciding. Second, third, fourth, and fifth is also not coinciding. In this case also, the sixth division of the Vernier is in straight line with the main scale division. Okay, so I will write that 6 over here, and that multiplied by least count, and least count happens to be 0.01. So 6 multiplied by 0.01, this will give me 0.06 centimeter, but being a negative zero error, I'll put a negative sign. So my negative zero error is 0.06 centimeter in this case. This is how you have to determine the zero error in any instrument, okay, rather in a Vernier caliper. Now, what this zero error has to be done, okay. Now, what happens is, whenever you take any reading, suppose you are taking the reading of a length of a particular object. So your reading will be divided into this category. First will be main scale reading. You have some main scale reading. Then you will have some Vernier scale reading. Then you will have a final reading, which is nothing but main scale reading plus Vernier scale reading. Okay. So final reading will be main scale reading plus a Vernier scale reading. Main scale reading plus a Vernier scale reading minus the zero error. So the zero error, if you have a zero error in your Vernier caliper, then it has to be subtracted from this main scale, the sum of the main scale reading and the Vernier scale reading. Okay. Now, if the zero error is positive, then you will have to subtract, okay, zero error from the sum of main scale reading and Vernier scale reading. But if the zero error is negative, then you'll have to, what you'll have to do is minus of minus will become plus. So you'll have to add the zero error to the sum of the MSR and BSR. Okay. So when we do some numericals on this particular Vernier calipers, we will be doing this also. Okay. That is using zero error also. So when you use a zero error, we say that the final reading is now known as corrected reading. So when you say corrected reading means the zero error that you have in the instrument has been used up. Okay. So if it is a positive zero error, you have to subtract it from the final reading. And if you have a negative zero error, then you have to add that particular value of negative zero error to the final reading. This is known as the corrected reading. So these are the terms: main scale reading, Vernier scale reading, final reading, and the corrected reading. So finally you have to consider the corrected reading for your calculations. Is that okay? Now, once you have understood the concept of zero error, once you have understood the concept of least count, now let us try to do this numerical from your IGCSE Tom Duncan textbook. Okay, now this is from your Tom Duncan textbook. I think it is your third edition. Okay, third edition, right? So these questions I could see in your book. Okay, and let us try to sort out this question, right? So this is some question number 11. Okay, and what it says, let me see. Now, what are the readings on the Vernier scales in this figure 1.14 A and B? So this is that figure 1.14, and this is your A, and this is B. Okay, this is A and this is B. So how to take the reading? So let us go for the A. Okay, now you can see that this top scale that they have given is a millimeter scale. Okay, this is the main scale, right? So your main scale is uh, this one. This is your main scale, right? So if you see properly, this main scale reading that you are going to record How we are going to record? See, you have to see the zero of the vernier. Can you see? This is the vernier scale, right? Now this is the zero division. Then this is the first division, second, third, fourth, and fifth, sixth, seventh, eighth, ninth, and this is the 10th division. So on this vernier caliper, you have 10 divisions, right? And these 10 divisions are adjusted into 9 millimeter. So this vernier caliper that they have given you the diagram is belonging to that category. Which category? 9 division on the main scale is equal to 10 division on the vernier scale. And hence you know the least count will be equal to, you have to use this formula, 1 MSD multiplied by 1 minus x upon y. So 1 MSD means 1 main scale division. Now this 1 main scale division, that is this division. Okay, this is nothing but 1 millimeter. So I'm going to write in centimeter. So it will be 0.1 centimeter, right? Multiplied by 1 minus. Now what is this x and y? Your x is 9. Okay, that is the number of division on the main scale, 9. And this 10 is what? It is y. So instead of y, I'm going to write 10. Now this works out to 0.1 times 1 minus 9 upon 10 is 0.9. This works out to 0.1 multiplied by 1 minus 0.9 is 0.1. And 0.1 multiplied by 0.1 will be 0.01 centimeter. Now this is the least count of this particular vernier caliper. So from the diagram, I have calculated the least count and I got the least count as 0.01 centimeter. Now the main scale reading is the zero of the vernier scale, that is this particular marking, okay, where it is coinciding on the main scale that you have to see. Now here, if you see properly, this is 50th mark, 50 millimeter, then this is 51 millimeter, this is 52, and your zero is lying somewhere between 53 and 54. So if the zero of the vernier scale is lying in between, so you have to take the lower reading. So I will take 53. I'll take 53 millimeter, right? But now because we are dealing with everything in centimeter, I'll write this as 50, or let it be 53 millimeter, no issue, okay? This I will convert into millimeter. 0.01 centimeter is 0.1 millimeter, right? So least count is 0.1 millimeter of this vernier caliper, right? So the main scale reading is 53 millimeter. I am taking the lower reading. Okay, it is between 53 and 54. So I am taking 53 millimeter. Vernier scale reading is what? Now from the left, you go to the right and see which particular division is coinciding exactly. Which particular division of the vernier scale is coinciding exactly with the main scale division. Okay, so if I see 0 is obviously not, first division is also not coinciding, second division is also not coinciding, but I can see this third division which is exactly coinciding. Can you see this third division? Yeah, this third division I have encircled with a green ink. So third division is coinciding. So that division I'll multiply by the least count, and least count I'll be taking in millimeter. So 0.1 millimeter. So this happens to be 3 into 0.1 is 0.3 millimeter. So this is your vernier scale reading. Vernier scale reading is always, you will always get vernier scale reading by taking first the vernier scale division. In this case, it was the third division. And that you have to multiply with the least count. That will give you vernier scale reading. Then what you have to do, you have to find the final reading. So final reading is main scale reading plus vernier scale reading, which in this case is 53 millimeter plus 0.3 millimeter. So your final reading should be 53.3 millimeter. Am I right? 53.3 millimeter. Now, here they haven't mentioned to you anything about zero error, whether this particular instrument is having any zero error or not. So we are not going to consider any zero error in this case, or in this case we have to assume that the zero error is nil. Otherwise, if there was some zero error, then that you should have taken into consideration, and whether it was positive or negative zero error, we should have accordingly, you know, done the correction, and the final reading or the corrected reading would have been slightly different than this 53.3. But in this case, we are assuming the zero error to be nil, and that is why our final reading we are keeping 53.3 millimeter. Okay. So this is the answer for the A part of the question. Now let us try to do the B part of the question. Now if you see the B part of the question, here again the main scale reading will be, now see the zero of the vernier, this is the zero of the vernier, where it is coinciding. So I can see that this is 90 on the main scale, this is 91 millimeter, 92 millimeter, 93, 94, and one second, 91, 92, 93, 94, 95, and slightly less than 96. Okay, slightly less. So you can say that it is in between 95 and 96, but slightly less than 96. So even if it is slightly less than 96, I should not be tempted to take it as 96. Okay, unless and until I am sure that it should be 96. But I can see that it is slightly less than 96. So I'll take the lower reading as 95 millimeter. Okay, even though it is more closer to 96, I will still take the lower reading as my main scale reading, that is 95 millimeter. Next is the vernier scale reading. Now vernier scale reading, how I'll decide? So go from left to right on the vernier scale. So zero division is not exactly coinciding, first division is not coinciding, second is not coinciding, third is not coinciding, fourth and fifth is also not coinciding, sixth is also not coinciding, seventh is also not coinciding, but this eighth division, can you see this eighth division? That is coinciding. So I'll take the eighth vernier scale division, which is coinciding, that I'll multiply it by the least count, and least count is 0.1 millimeter. This will give me the vernier scale reading as 0.8 millimeter, right? So my final reading will be main scale reading plus the vernier scale reading, and because zero error I am assuming to be nil, so I'm not doing anything about zero error. So main scale reading and vernier scale reading, if I add up, it will be 95 plus a 0.8, and this gives me 95.8 millimeter. Is that clear? 95.8 millimeter. Now here, these readings that I have got, okay, are in millimeter, and that is why you can see that the accuracy is of 1 dp. But if I would have taken the readings in centimeter, the accuracy would have become 2 dp. Okay, because the because my least count in that case would have become 0.01. Now this entire set of reading, if I want to convert it, if I want to take in centimeter, then right from this stage I would have done the conversion. Okay, so instead of 53 millimeter, I'll write 5.3 centimeter, right? Instead of this vernier least count as 0.1, I would have taken 0.01 centimeter. In that case, my reading would have been 0.03 centimeter, right? Can you see that? Now, my final reading would have been this 5.3 plus 0.03. In centimeters I'm talking about. Okay, in millimeters this is the right answer, right? But in centimeters my final reading would have been 5.33 centimeters. You getting me? Now here you can see that my accuracy is of 2 dp, 2 decimal point, because I have taken the reading in centimeter, and in centimeter my least count is 0.01, which is indicating 2 dp, right? Same way over here. So either you can give your answer in millimeter as 53.3 and 95.8 millimeter respectively, or you can give your answer as 5.33 centimeter, and here you can give your answer as 95 point, I think this should be 95.08 centimeter. So anyways, both your answers are correct. Whether you give your answer in centimeter, oh, this should be 9.58. Sorry, because this will become 9.5 centimeter. This will become 0.08 centimeter, and when you add this you will get 9.58 centimeter. So either your reading should be in centimeters, these are their answers, or in millimeters, these are your answers. Okay. In the Tom Duncan book, okay, I have seen the answer to both these questions A and B are given in millimeter as 53.3 and 95.8 millimeter. So that was about the zero error of a vernier caliper and how to take a reading using a vernier caliper. Now in the next session, I will come up with more problems, okay, where you will not have these diagrams, but there will be some word problems. And from the word problems, you will have to, manipulate what is the least count, what is zero error, and how the final reading has to be evaluated. Okay, so those questions also we'll be doing in the next video. And after that, we'll be coming to micrometer screw gauge also. Okay, so that's all for today. See you. Bye. Take care, all of you.